Hello everyone, Dr. Zia Tahir here. This video tutorial is first lecture of beam analysis in Abaqus CAE series, and this video tutorial is about 2D simply supported beam subjected to a point load. The length of the beam is 3 meter and a point load of 12 kilonewton is being applied at 2 meter from left support and 1 meter from right support. The beam is made up of wood with modulus of elasticity 12.5 gigapascal and Poisson's ratio of 0.3. So this video tutorial is a detailed one compared to the other one. And I have created chapters in this video tutorial. So if you want to skip any subject, chapter or step, so you can directly go to that chapter which is your concern. So here need to determine deflection under the load and reaction forces, and then need to plot shear force diagram and bending moment diagram. Any analysis in Abaqus contain two parts. One is model and other one is result. So first part is model. So I am going to follow these steps for model, and for each step I have created a chapter. Then is analysis to create job. Second part is result, and for results, so I'll follow these steps, and for these steps I have created chapters. There are no predefined units in Abaqus CAE, so you need to select your own set of units for dimension, loads, and stresses, and then you need to be consistent with that. So in this problem, for load I'm using newtons, dimensions I'll use meter, and stresses I am going to use Pascal. So you need to set work directory. So work directory is a folder where you want to save all your results. So here is a folder where I want to save my model and results. So I just copy it, and then here is Abaqus. I am using Abaqus CAE 2020. So file, set work directory, and just paste here the link of that work directory, and then you can save that model. And I'm going to save that beam 2D SS, click OK, and now you can see that in the work directory. So that is beam 2D SS is a folder, and then this model is being created there. The first step is using part module, need to create part. And here in Abaqus, you have here module. So these are the different modules here, or you have model tree here. So that is a model. If I expand it, and then in the model tree, you will find out these different modules. So you can create part by using that module, or if you change that module here, so you can see that tabs are going to change. So in the part module, here you have option to create part, or click here to create part, or create part. So now in the part, you'll have that part name, then modeling space I'm using 2D, type is deformable, and then base features is a wire, and approximate size. This approximate size is almost double of the maximum length, so which is 3. So 3 times 2 is 6. So I'm going to set it as like 10, and I'm going to name that part as beam. So continue, and now this is XY plane, and in XY plane I can use that connected lines to create part. And to create that beam, you have two options. One, you can model it as 3 meter beam and then create a partition here. So to create partition, in the next video I'll show how to create partition, but for this one I am going to create this beam in two span. So one from support to load, and then from load to other support. So that is 2 meter and then 1 meter. So here with the connected lines, so you can start with either by clicking mouse here, and then you can move forward to go to 2 meter. Okay, so like on the top right somewhere here, you can see what are the coordinates. So that is 2 meter, that is a from left support to the load, and then the next one I can enter here in 3 and 0 for 3 and 0 for other coordinates. Just enter. So now you can see beam in two parts is being created. So from here you can auto fit view, and the next one here you have option to add dimension, auto dimension, and then select the part or sketch. So done, and you can see that it is 2 meter and 1 meter, and that is done, and again done. So now that beam is created. Next step is create material, and the material is wood. I'm going to name that as wood. Need to add E as 12.5 E raised per 9 E9, and modulus of Poisson's ratio as 0.3. So to create material, now you have further, you can use property module. So that is a property module, and the first one is to create material, or in the model tree you can create material, or from here you can create material. So I'm just double clicking on create material, and material name is wood, then mechanical, elasticity, and then elastic, and need to add values 12.5 gigapascal, and then the Poisson's ratio is 0.3. So these are Young's modulus and Poisson's ratio. Click OK, and then you can here see material is created. So if you want to modify anything in the material, so just double click it, and then you can modify the value. Next step, in the property module, need to create profile. So the profile is rectangular, and you need to add its width and depth as 100 E-3 and 200 E-3. So again, here in the property module, you have here create profile, or you can, in the model tree, you can create profile. I named that as rectangular, and then here you can select rectangular. So continue, and now you need to add value of A, which is the width, and B is the height. So I added width of the beam as 100 E-3, and then depth as 250 E-3, because these values were in millimeter. Click OK, and then you can see a profile is created, so you can modify it by clicking that profile. Next step, in the property module, need to create section, category beam, type beam, and I'm going to name that as SS beam. So here you have again in the property module, so you have here create section. Okay, so that is a create section, or otherwise you can click here to create section. So section, name that as SS beam, and category is shell, and beam, and then type is beam. To continue, and now it asks profile name. So profile already created rectangular, and material is wood, and then you click OK. So now you can see that SS beam profile is being created there. Next step, in the property module, need to assign beam orientation. So select sketch beam. So here in the property module, you have here is assign beam orientation. So click on assign beam orientation. I'm not interested in creating set, so select the region to be assigned beam orientation. So I'm going to select that, and then done, and I'm not interested to change anything, so just click enter, and then you can see that orientations are being defined. So OK to confirm input. So now done, and now beam orientations are defined. Now the next step is in the property module, assign section, and assign section region, select this, and then section SS beam, and then you can view that beam profile. Again, here in the property module, you have this option as assign section. You can go here and assign manager, or otherwise in the part beam, you can go and click on section. So section assignment, it says select the region to assign section. I'm going to select that beam, so that is done, and now section is already one section created. OK, and then done, and it turned to green as you can see, and here is a section assigned. Next step is to create mesh, and it contains three parts. Seed edge, so select edge, and then apply mesh part, and then assign element type, and then view nodes. So again, module, mesh module. So in the mesh module, you have here seed edge. So seed edge, click on seed edge, and it says that select the region to assign local seed. So I'm going to select that beam. So done. Now you have two options here, basic by size or by number. So you can go by number, and that is between the vertices, but I'm going by size, and I'm going to keep that 0.1 meter as size. So this is all your choice. So you can either use a fine mesh or a coarse mesh. So if you will use that fine mesh, so then computation time will be high, and for coarse mesh computation time will be low, but results are not that accurate. So to check or to check that which mesh is appropriate, you need to perform a mesh sensitivity study. So just apply it, and now you can see here, so you have on the vertices rectangles, squares, and these are the seed. So apply, okay, done. Next is to mesh part, and here you have option to mesh part. So yes to mesh part. Next is to assign element type, and there you have assign element type. Okay, select a region to assign, so select beam, done. And now you have option family is beam, element library standard, geometric order linear, and that is a B21 two node linear beam in plane. So I click OK, so then done. So next one, if you want to view mesh or part, so then you can go here in the view, and then you have here part display option. The part display option, and in the part display option you have journal, and then journal, here you can see beam profile. If I apply it, so then you can see beam profile. Okay, and then you have here mesh. In the mesh, show node labels, show element labels, apply. Okay, and now you can see that, so these are the nodes and labels. So nodes are shown here in purple, and the labels are shown in red. So I can go view again, part display option, and I can check, uncheck, or check if you want. So I'm going to uncheck it, apply, okay. Next step is in assembly module, create instance, and create instance from part and select part. Again, here you have in assembly module, so that is assembly module, so you can create instance, or otherwise here you have assembly module, so click on instance, click on instance, and then you have here create instance from part, which part is beam, and just okay, and now you can see that instance is being created. Next step is create step, and procedure type is journal. I'm going to name that as static load. So now again here in the module you can go to step, so that is a step, and then you can create step, or otherwise here you have step. Okay, so I'm going to create a step, so that is a static load, and then procedure type is journal, and then static journal. So just continue and leave everything default. So now you can see in under that step a static load is created. Next step, in the step module, modify or create field output. So displacement and reactions are required, and for shear force and bending moment need to select NFORCSO. And in the step module, here you have option to create field output, or otherwise in the model tree already field output is being created, so just click on it to modify it. Now strains are selected, so I'm not interested in stresses and strains, not in contact, but displacements and translation and rotational displacement I am interested in. And then in the forces, reaction forces and moments, concentric forces and moments are selected. So I'm not interested in concentrated forces, but I am interested in FNFR, FORCS, so nodal forces in beam section orientation. So click OK. So now field output is being modified. Now next step, in the load module, need to create load, and load is a concentrated force and need to input as -12 E minus 3. So now again here in the load module, here is a load module, so you can create load here, or otherwise here you can see there is a load. Double click on load, and this load 1, or I am going to change its name to point load, and then step is static load, mechanical concentrated force. Continue and select the point of the load. So that is the point where load is applied. So done. And now you need to add value. CF1 is concentrated force in horizontal direction, and CF2 is a concentrated force in vertical direction. So I'm going to add that -12E minus 3. Okay, and you can see that load is being applied here and here under that load. So a point load is being created. Now next step is create boundary condition. So there are two boundary conditions. On left it is simply sport, and on right is a roller sport. And I'll go here. So now in the load module, you have the second one to create boundary condition, or you have that BC, so you can create there, or otherwise in the model tree right there you have BC. So click on BC. So pin on the left one, and step is initial. So name that as pin. Step is initial mechanical displacement and rotation. Continue. Now select the region for boundary condition. So I'll select that point as a region of boundary condition. Done. And now it asks about that which one you need to set as 0, because the pin sport and the pin sport displacement in horizontal direction and vertical direction both are 0. So I'm going to click OK. So now you can see that in boundary condition a pin sport is created. So the next one is roller sport. So roller sport on right. So here I have option to create boundary condition. So click, and I'm going to name that as roller. So at rollers, and then step is initial, category mechanical displacement rotation, and continue. And it says that select the region for boundary condition. So I'm going to select that point, and then done. It is a roller sport, and on roller sport only u2 is equal to 0 because free to rotate in horizontal direction. So click OK. So now you can see that roller sport is created. Now all steps in modeling, they are done. And now the next step in the analysis, need to create job using job module. I'm going to change model name, then data check and submit. So here you have in the module job module. So that is a job module, create job, or otherwise in the model tree. So here I have model, and here in the analysis I have job. So I just double click on job, but before that I need to change that model name. So the model name is beam SS. I kept it, and then for job double click on it, and then you have job. So I'm going to name that as beam SS. So continue, and then leave it everything as it is. So now you can see that a job is being created. So the next one, by right click on it, so you need to apply data check. So data check will help you to find that if all necessary steps in the model are performed, so it is running, and then if everything is okay, so it shows you check complete. So check is complete, so it means that all necessary steps are without are done and no one is missing. So then I can right click on it and then submit job. So once it's submitted, and then its status change running, and then after some time it is being completed. Job is being completed. So with that job complete, analysis is done, and first part model is done. And here you can see that the first part model is done. Now the next step part is results, and how to get that result. So you have options here. Right click on job and click on results, and then you can see in the results, so output database, that is a job which you have created at BMSS, or otherwise other option is file open, and then you can open that ODB, okay, like that way. So click OK, and now that job is being results. So in the result section you can see that result file. So once you got your results, then the first step in the visualization module is to go and check that field output dialog, common option, show node labels, and other stuff. So here you have visualization, and there is a field output dialog. In the field output dialog, so you have different options, but first I am going for these common options. So if you click on common options, so new window will open, basic, and it is now labels. So show element label, show node label, show node symbols. I can change that color to the red for node symbols, or like white for the node symbol. Apply, and then you can see here in the deformed one, auto fit view. So these are node labels and symbols. So it is autocomplete, man, it is 82 times of that original deformation. So I'm not interested in showing not node labels. So apply, and now you can see that only nodes and their symbols are displayed. If you want to see a deformed beam here, so you can view and then ODB display option, and you have that render beam profile, okay, and in this way you can see that deformed beam. And on the deformed beam, if you want to see the contour plots, so here you have option for contour plot, and if you want to check that both deformed and undeformed, so click that, and then option will appear. So this way you can see that deformed and both undeformed. So if you uncheck that random beam profile, or I can change it beam profile to like 1.1, or like scale factor is half, so then you can see that deformed and both undeformed beam. Apply, okay. So I'm not interested in both deformed and undeformed, so this way you can visualize results in XY plane or in isometric, and there. The next step is to find deflection under the load. So I'll go in the visualization mode and then use prop value, and I'm going to write a file. So here you have, first you need to go in primary and then U, and then in U you have U1. So you can see that is U1 and that is U2, but I'm going to keep it as magnitude. And then in the tools you have option for query, the query, and then in the query you have that prop value. So that is a prop value, or otherwise you can directly go here in the prop, and then you can have that prop values. Okay, so I select nodes, and remember one thing here, like if I go into the undeformed model, so how I have created the beam. So like I started from this point and then on 2 and then 3. So Abaqus usually create in a sequence. So that 2 is a point where load is being applied. So then to prop value, I'll go here, nodes, and then component I'm going to select all. All mean that both U1 and U2, and then you can key in label, or you can select a display group. So if I click on key in label, if I know that node label, so that is the node label 2. So I just key in 2 there, press enter, and it gives me deflection. Or if I click here, so now you can see the values. So the values are not very prominent, so I can change viewport background. It's very simple. So I can go view in graphic option, and then I'm going to change it to white, apply, and now the node labels are not that much prominent, but you can see that here are the deflections. If you want to find deflection on all nodes, so it is very simple. Select a display group and then all. Okay, so now all nodes, you can see they are being selected. So if you click on that, so then you can have the values, but I'm not interested in all that. So I'm going to write a file. So when you are going to write a file, so file name, I'm beam ss, and then you can have other option. So output format, so number of significant figure. So I am interested in 6 significant figure. Number of format is engineering. So I click OK. So that beam ss report is being saved in your work directory or folder. Okay, so click OK, and then I can go here, and then beam ss rpt is being created. Here you can see that beam ss rpt. I'm double clicking it. So then you can see that here variable u all direct, and here are u1 and u2, they are being created. Next step is to find reaction forces at sports. And so for reaction force in field output dialog, here you have RF and RF1 and RF2. So these are the two reaction forces. So I'm going for magnitude, and then I can either go to tools, theory, and then prob value. So these are the prob value. Now I'm interested in reaction forces, and remember that reaction forces are at first node and at the third node. So now component, and I'm going to key in label. So node 1 and then node 3. So these are the reaction forces at node 1 and 3. So if I click here, so you can see that it is 0 and 800, because this is a roller sport, so no reaction in horizontal direction. But here you have in vertical direction a very low value of or almost 0, and then in that is horizontal direction, and in the vertical direction it is 400. And if I want to get for all nodes, so click all, yes, and you can see that so reaction forces are only present at the sport, and on other nodes reaction forces are 0. But I can write to a file on the same one, I can append it. Okay, so if I open that file again, beam ss, so you can see that there the second one is reaction forces all direct, and these are, that is the report. But because only on the sport, so you can find out the reaction forces. So at node 1 and at node 3 reaction forces are present. Next step is to create path, and why that path is being created, this is to create shear to plot shear force and bending moment diagram. So in the visualization mode, when you are in visualization mode, okay, so then tools, and you can go here and create path, or otherwise in the result tree, so you have here path. So just double click on path, and then you have option path 1, and type is node label. I rename that path node list 1, and that path node list 1 is only for nodes where are sports and loads. So I'll go continue, and now it is here I have different option. So it's the viewport selection, add before. So then you can select from viewport, so that is the node 1, then it is node 2, and then it is node 3. Okay, so done. So you can see that here 131, or I can go 1 2 3, that is another option. So the default is 1 to 3 with the step size of 1. Okay, so I click OK, and now you can see that a path is created, and this is for only 3 nodes. But if I want to create now I'm going to create another path for all nodes, and its name is path node list 2. So continue, and then viewport selection, add before, and now need to select all nodes one by one. node selected, I select done, and now it says that 1 and then 4 to 22. So that is 4 to 22 with the step of 1 and then comma, the next is 2 and then 20 to 31 with the step size of 1. So either you can select all those nodes manually or 1 comma and then 4 to 22 with the step size of 1. So all nodes in that sequence, and then comma 2 and then after 2, or if the nodes are in sequence, so 22 to 31 with the step size of 1 and 3. So click OK, and now you can see that this is the node path 1 created, that is a node list path 2 created. Next step in the visualization, create XY data, and this is to plot shear force diagram. And in field output, you need to select NFORSCO, and source is the path, so you can select any of the path. And X values are the two distance. So now here in the visualization module, so you have option here to create XY data, or you have option here to create XY data. So let's say I click here to XY data, and now it gives you source. Source is the path, continue, and now it is path. I have two paths. First I'm going to plot for 1, and X values is the two distance, and the field output I'll select that, and this one, nodal force in beam section orientation at element node. So this is in a vertical direction. So select that, apply, OK, and then you can plot. Because there is a point load, so this is the shape for the point load. And then if I click on node path 2 and I plot, so you will see that it is the same one because of the point load. But if it is a UDL, so then you need to select all node list, because it will show then discontinuity. So plot, and then I can save as. Save it as shear force diagram. Okay. And now in the XY data, so you can see that shear force diagram there. And then you can change that shear force diagram by clicking here. You can change its background, and then by clicking here you can change its like from force to shear force, and this is the length here. So I change by going on title, so length of the beam, and then you can change it to the bold, apply, OK. And the other one is the shear force. You can simply dismiss that. If you want to add title, so just double click on it, and so just double click here, and then you have option for title. Sorry, to add title, so just double click on that legend, double click it, and now you have title. So there is no title. So like a shear force diagram, and then area, I'm going to keep it as a top, and content, if you want to bold it or change its font size, so you can. Here that's the shear force diagram for the node list part 2. So that is all about plotting and then changing their axis. Now the next step is to plot bending moment diagram, and for field output need to select NFORCSO, create XY data. So it is now I can go to check that what is the deformed model is, and then I click here to create XY data. So create XY data, and the source is path, continue, then node list 2 I'm going to select, X values is 2x distance, field output request this time is the nodal force in beam orientation, so that NFRCOS6 is, that is a moment about Z axis. Okay, so select that, apply, OK, and plot. Now see here, because I have changed the title, so it is still showing me the shear force, and here you can see that moment. So I can change that moment to whatever I want, like here in the title. So instead of moment, I can go bending moment, and then you can change the title. Okay, so that is the bending moment. If you change the title, so just double click, change to bending moment diagram. So that is bending moment diagram, and then you can simply, here you have as temporary, that one is temporary, so you can simply save. Oh sorry, is being removed from accidentally from there, so then I have to plot it. Is being plotted, and then save as. Instead of XY data, bending moment. So the name is bending moment diagram. Okay, and you can see that bending moment diagram there, and that is the bending moment diagram plotted, and all from result section. So result section, whatever is required, so those values are found, and then shear force and end bending moment are plotted. The end summary. This video tutorial was simply supported beam analysis in Abaqus CAE. So simply supported beam of 3 meter length subjected to 12 kilonewton concentrated load was analyzed. For deflection under the load, reaction forces to plot shear force and bending moment diagram. So these are the results which I got from hand calculation, and those results of analysis, they are exactly the same. The first one in step in the modeling, you need to create part, material, profile, section, assign beam orientation, assign section, create mesh. To create mesh, that size is your choice, and mesh size depends upon like accuracy of result depends upon mesh size. But if you are going to decrease element size, so results might be accurate, so you need to perform a mesh sensitivity study for that. Then you need to create instant to assemble that, create step, then modify field output, then you need to create load, create boundary condition, and then analysis, you need to create job. And in the results, uh, deflection and reaction forces were required. So using prob values, I found that deflections and reaction forces, and then I create a report file so that those values are saved. And then I created a path for shear force and bending moment diagram. And for shear force diagram, field output was NFORCS2, and then for bending moment is 6. So this is all about this tutorial. I hope you find this video tutorial helpful. Thank you very much for watching, and if you have any feedback, you can leave in comment section.